Hold on. Helium-powered air surfing will blow your mind.
No, it won't. I first found the board you were standing on, the Aquamarina inflatable subboard. Now the question is the upward buoyant force greater than the downward force due to gravity for your board to float? According to the video, you're using helium to fill the board. I know you recorded this video sometime in March of 2021 in Switzerland. I won't share the exact location because it's close to where you live. The average temperature there since it was daylight was about 50 Fahrenheit or 10 degrees Celsius. The elevation was 738 meters. I needed to know where you were because I need to now calculate the density of the helium inside your board and the density of the air around it. According to the ideal gas law, PV equals nRT or M over M times RT. The density of the helium would be M over V. P is the pressure which we know inside the board you're using is 15 psi. But that's the gauge pressure. We also need to add the atmospheric pressure to this, which can be calculated using this formula that needs your temperature and elevation. That means the total pressure is about 1.93 atmospheres.
M is the molar mass of helium at about 4 grams per mole.
R is the ideal gas constant and T is the temperature in Kelvin. We can then calculate the density of the helium inside your board to be 0.33 grams over liters. The mass of the helium inside your board would be this density times the volume, which would be 0.1 kilograms, which means the total mass of the board including the helium is 9.8. Times gravity, that is a downwards force of 96.17 newtons. According to Archimedes' principle, we need to figure out if the buoyant force is enough for your board to float. The buoyant force is the volume of the board times the air density times gravity. Using the same method as the helium, I then calculated the air density around your board to be 1.14 grams over liters. This means the buoyant force is just 3.6 newtons, which is much less than the 96.17 newtons of downwards force. So now, that board isn't floating with you on it. It's not even floating by itself.